There's a phrase being thrown around in AI right now that sounds incredibly simple. Open source model. You download the weights, you can run it yourself, you can fine tune it. No API required. Open source, right? Not necessarily. And Kimi K3 might be the clearest example yet of why the AI industry needs to stop pretending that open weights and open source mean the same thing. Because Moonshot AI did something surprisingly important with Kimi K3, they actually called it what it is, open weight. And once you look at what that means, a huge amount of supposedly open source AI suddenly becomes much harder to call open source. In normal software, open source is reasonably straightforward. Take something like Linux. You don't just get the finished executable, you get the source code used to build it. You can inspect it, you can modify it, you can compile your own version, you can redistribute that version under the terms of its license. The source is effectively the recipe. But AI models change this relationship completely. Imagine a company trains a gigantic model using trillions of tokens, proprietary filtering systems, reinforcement learning environments, internal datasets, and enormous compute infrastructure. Then at the end of that process, they upload the resulting model weights. Those weights might be downloadable, you might be allowed to run them, you might even be allowed to modify and redistribute them, but you still haven't necessarily received the source of the thing in the traditional sense. You've received the result of the training process. And that's an important distinction. The open source initiative's open source AI definition makes this distinction explicit. Its definition says an open source AI system should provide the freedoms to use, study, modify, and share the system. But importantly, it also says the preferred form for modifying an AI system should include information about the training data, the code used to train and run it, and the model parameters themselves. In other words, weights are one component. They are not automatically the entire source. Here's an easier way to understand this. Imagine I build an application. The code is secret. The build system is secret. The libraries I used are secret. The configuration is secret. But I give you the compiled executable. And I tell you, you're free to run this executable. Maybe I even let you modify parts of the binary. Would you describe that application as fully open source? Probably not. Yet with AI, we've somehow become comfortable doing almost exactly that. A company releases a checkpoint and suddenly headlines appear saying, new open source AI model released. But the checkpoint is effectively the compiled artifact of an unbelievably expensive training process. The weights tell you what the final network became. They don't necessarily tell you exactly how to recreate it. That's where the term open weights is much more useful. It makes a narrower promise. You can access the parameters that's valuable, extremely valuable. But it isn't the same claim as saying the entire system is open source. This is where Kimi gets interesting. Moonshot AI's previous Kimi K2.5 repository explicitly described the model as open source. Its repository says both the code and model weights were released under a modified MIT license. Then Kimi K3 arrived, and the language changed. Moonshot describes K3 as an open weight model. Specifically, they call it an open weight native multimodal agentic model and say they are releasing its full model weights under the Kimi K3 license. That distinction matters because K3 is massive. We're talking about a 2.8 trillion parameter mixture of experts model. Only around 104 billion parameters are activated during inference, and it supports a context window of roughly 1 million tokens. This is exactly the type of model people would casually call open source. You can get the weights, you can deploy it yourself, you can fine-tune it. Moonshot even provides information around inference and training, but their own terminology is telling you open weights, not simply open source, and then you read the license. The Kimi K3 license is actually very permissive for most developers. It explicitly gives people rights to use, copy, modify, publish, distribute, sublists, sell, deploy, and fine-tune the software, including the model weight. If you're experimenting locally, researching, building an application, or running Kimi internally, that is an enormous amount of freedom. But there's a catch. If you're operating what's effectively a model as a service business and you or your affiliates generate more than $20 million in revenue across a consecutive 12-month period, you need a separate agreement with Moonshot before using Kimi K3 commercially in that way. There's another condition too. If a commercial product using Kimi K3 exceeds 100 million monthly active users or $20 million in monthly revenue, the product has to prominently display Kimi K3 in its interface, subject to the license's exceptions. Now compare that with one of the core ideas in the open source initiative definition. An open source AI system should be usable for any purpose without asking permission. That's where the terminology starts to matter. Kimi K3 gives developers tremendous access, but access and open source are not identical concepts. And Moonshot isn't even hiding this. They're calling it open weight, and this is the important part. This isn't an argument that Kimi K3 is somehow closed. That would be equally misleading. There's an enormous spectrum between you can only access our model through our API and Every ingredient required to independently recreate our entire training pipeline is publicly available under open source terms. Open weights sits somewhere along that spectrum. And for developers, open weights can give you most of the benefits you actually care about. You can run the model on infrastructure you control. Your prompts don't necessarily need to leave your environment. You aren't permanently dependent on one API provider. You can quantize it, fine-tune it, distill it, study its behavior, build inference systems around it. And if the original company disappears tomorrow, the weights don't automatically disappear with them. Those are massive advantages over a completely proprietary model. So, open weights shouldn't be treated as an insult. It's actually an incredibly useful category. The mistake is pretending the category doesn't exist. Hey, don't forget to like and subscribe for more like this. Now, back to the video. Instead of treating AI models as either open or closed, it makes more sense to ask exactly what has been released. Are the weights available? Is the architecture documented? Is the inference code available? Is the training code available? Do we know the hyperparameters? Do we know the data mixture? Do we know how the data was filtered? Do we have the reinforcement learning environment? Can somebody with enough compute independently reproduce something substantially equivalent? And what does the license actually allow? Those questions tell you far more than a giant open source label on a model announcement, because two downloadable models can have completely different levels of openness. One might use Apache 2.0. Another might contain restrictions on particular commercial uses. One might provide a detailed technical report. Another might provide little more than weights and inference examples. One might disclose significant details about its dataset. Another might simply tell you the approximate number of training tokens. Calling both of those things open source removes information instead of adding it. And training data is probably the biggest reason this debate isn't going away. The open source initiative doesn't necessarily demand that every individual training sample itself be downloadable. That would often be impossible because datasets can contain copyrighted, licensed, private, or otherwise non-redistributable material. Instead, its definition calls for sufficiently detailed information about the training data so that a skilled person could build a substantially equivalent system. That includes things like provenance, characteristics, selection methods, processing, filtering, and listings of publicly or commercially obtainable data where applicable. That's a much higher standard than, here's the model checkpoint. And suddenly you can see why so many models that get described online as open source are more accurately described as open weight. The hardest part of building a frontier model isn't loading a tensor file. It's producing that tensor file in the first place. Think about a car factory. If Toyota gave you a finished engine and said, you can take this apart, modify it, and put it in your own car, that would be incredibly useful. But they haven't necessarily given you the factory. They haven't necessarily given you the manufacturing process. They haven't necessarily given you the tooling. They haven't necessarily given you every material specification. AI weights are similar. The weights are the product that came out the other end of training. Training code, dataset composition, pre-processing, reinforcement learning, reward models, evaluation pipelines, and compute infrastructure are the factory. And the AI industry has spent several years calling access to the engine access to the factory. You might wonder whether any of this is just semantics. For someone downloading Kimi to write code, maybe it is. But for the wider AI ecosystem, it matters enormously because open source carries expectations. It implies independence, reproducibility, transparency, forkability, the ability for a community to continue the project without the original company. Those concepts are much harder with frontier AI. If Moonshot stopped developing Kimi tomorrow, developers could continue running and modifying Kimi K3's released weights. That's real openness. But could the community reproduce the complete process that created Kimi K3 and independently train its true successor? That's a completely different question. And that gap is exactly what the phrase open weights captures. And there's another reason this distinction matters now. Commercial restrictions on downloadable AI models appear to be becoming more interesting to model companies. Reuters reported this week that Alibaba is planning licensing changes around its upcoming Qwen model for large commercial users. With an approach compared to Moonshot's Kimi K3 licensing model, that's significant because the frontier isn't just splitting into closed and open models anymore. We may be heading toward an entire licensing spectrum. Fully proprietary API, source available systems, open weight research models, open weight models with commercial thresholds. Permissively licensed models, and genuinely open source AI systems meeting stricter definitions. That means developers are going to have to start reading licenses instead of relying on marketing labels. Which brings us back to Kimi. The interesting thing isn't that Moonshot somehow exposed a dirty secret. It's almost the opposite. By describing Kimi K3 as open weight, Moonshot is using language that's arguably more accurate than the language the industry has been using casually for years. You get the weights, you get substantial freedom, you get the ability to deploy an extremely capable frontier-level model yourself. But there are still licensing conditions. And possession of the weights does not magically mean possession of every ingredient required to recreate the entire model from scratch. That's okay, we just need better words for it. So here's the rule I'd use from now on. If somebody tells you a new AI model is open source, don't immediately ask, can I download it? Ask, what exactly is open? The weights, the inference code, the training code, the data recipe, the dataset, the reinforcement learning pipeline. And under what license? Because I can run this model locally and this AI system is open source are two completely different statements. Kimi K3 makes that distinction unusually obvious. And ironically, calling it open weight doesn't make Kimi less impressive. It makes the description more honest. Open weights are incredibly important. They might be one of the biggest forces keeping frontier AI from becoming completely controlled by a handful of API companies, but open weights are not automatically open source. And as these models become more powerful, more expensive, and more commercially important, that difference is going to matter a lot more than most people realize.